So this is a demo of a z-test. Okay, we are going to use the practice computation question number 1. Okay. So here the data is based on this. The following is IQ scores of 7 people, IQ who has ADHD. So this means you have 7 people here and 7 people's IQ test score. Okay, and then the problem that we are actually trying to solve is number 1. Examine whether the mean ADHD people's IQ is significantly different from population mean of IQ score, which is 100 using population standard deviation of 15. So this is a typical case of z-test because first you have a population mean available, which is 100, and then you also have population standard deviation available to you, which is 15. So what you're doing is the hypothesis, the null hypothesis that you're testing is mu ADHD equal 0. Alternative hypothesis is mu ADHD is not 0. And then we are going to use alpha level of 0.05. Okay, so first, alpha level equal 0.05 is basically the same thing as 95% confidence interval as you have learned by now. So you use z table. Okay, 95% means half the mountain is 47.5. So therefore, what you look at is B is here. This one, B of 4.475. The corresponding B score is 1.96. Okay, so this means Z critical equal 1.96. So what you need to do is to compute Z observed. Okay, so Z observed is how you are going to compute it. Okay, so mean minus mu divided by standard error. This means you already know it's 100 is the mu, because that's the mu that you're comparing, which is the population mean here is 100. Okay, and then x bar is the actual sample mean, which is based on these numbers. So let's compute sample mean. So 97 plus 110 plus 101 plus 99 plus 108 plus 129 plus 185. This is a total score, and divided by 1, 2, 3, 4, 5, 6, 7. So that's 111.29. So 111.29 minus 100. Standard error. Okay, so how are you going to get the standard error? Standard error is a standard deviation divided by square root of n. We know the standard deviation to be 15. So therefore, 15 divided by square root of 7. So 7 square root is 2.65. So therefore, 15 divided by 7 square root equals 2.65. So that means 15 divided by 2.65. 5.66. That's the standard error. So this means denominator is 5.66. Numerator is 111.29 minus 100 equal 11.29, and then we are going to divide this by 5.66 equal. Okay, so this is 11.29 divided by 5.66. That's 1.99. So therefore, Z observed equal 1.99. This 1.99 is larger than 1.96. This means this is 1.96 and this is 1.99. Therefore, this is the common area. This is a layer area. So this means, given the null hypothesis, the value of Z observed to be 1.99 is very small. It's unlikely if the null is true. Therefore, we reject the null hypothesis. So basically, we are going to choose. It's basically rejection of null hypothesis.